On we go to the second question. I'm going to try and go a little bit more quickly through these ones just so that we save ourselves a little bit of time. I don't have to post so many videos. But anyway, number 2. Explain how you could titrate 485 mils of an acidic solution with a 3.00 normal base. So let's just make a couple notes. We've got 485 mils of some acid, well, acidic solution. And then we're going to titrate this with a 3.00 normality base. Okay. What would the normality be? So we're looking for normality of the acid if it required 0.390 liters of the base. 0.390 liters of the base. So that's going to be volume of the base to reach the equivalence point of titration. So just noting that equivalence point, this means neutralization has occurred, right? That's what we're thinking. So neutralization occurring, titration, right? We're looking to figure out normality based on the information given. It looks like we're going to be using this formula to solve for the normality of the acid. Okay, so we have that formula there. Now this is just where we're starting. Remember, we do also have to explain. We have to explain the titration process. All right, so anyway, let's get back to solving this. So normality of A, that's what we're solving for. Normality of the base, well, we said it was 3. Volume of the base, we said it was 0.390 liters. Volume of the acid, 485 mils. And if you're watching and following along, you're thinking, Mr. Martins, you're about to make a mistake. No, I'm not. Okay, remember, both volumes have to be in the same units. Okay. So this gives us a normality of 2.41. Okay, so that's the normality. But then we also have to explain how we titrate this. So titration steps, first off, you need to add 485 mils of acidic solution to Erlenmeyer flask. Okay, that's the first step. If you guys recall the lab, after this, we need to add an indicator to the flask, right? And I'm abbreviating this for the sake of speed. And then we will add measured amounts of the 3.00 normality base to solution until indicator shows that the solution is neutral. Okay, and that is question 2. Okay, let's go on to question 3. Question 3, we have 13 mils of 0.4 molar phosphoric acid. Okay, phosphoric acid, so phosphoric, right? That's naming rule 3. That means the anion has to be phosphate. Remember, we always add a hydrogen. Phosphate has a 3- charge, so that 3 is going to end up down there. So H3PO4, this is phosphoric acid. It is neutralizing 5 mils of calcium hydroxide. So we remember calcium hydroxide from question 1. It's asking us, what is the molarity of this substance? We're asked about also the number of equivalents of phosphoric acid, and we're asked about the normality of phosphoric acid. So first thing we have to do is write out the neutralization reaction. So we have phosphoric acid plus calcium hydroxide. Oops. right? And remember, we're going to create water and a salt. You can also think of this as a double replacement reaction, the hydrogen and calcium just trading places. So our salt, we're going to have calcium phosphate, right? Nice complicated formula for that. And we're going to have water, H2O. Then it needs to be balanced. Okay, so balancing, gonna have to put a 3 here to match up that. And then let's put a 2 out front here because we have 2 phosphates. So we have now 6 hydrogens, put a 6 out here. Okay, and that looks good. Now we can go about calculating what we're supposed to calculate. So molarity of calcium hydroxide, let's do that one first. Well, we are told the molarity of phosphoric acid. So 0.4 moles per liter. That's phosphoric acid. We have 0.013 liters of phosphoric acid. I just converted milliliters to liters by dividing by 1,000. Okay, so cross out liters. This is going to leave us with moles of phosphoric acid. So we want to go moles phosphoric acid to moles calcium hydroxide. So to do that, we need our balanced equation. So we're going to put moles phosphoric acid on the bottom, 2 moles H3PO4, 3 moles calcium hydroxide. And I'm doing this all in one big step, right? You can do this in multiple steps. So now moles phosphoric acid are done. We're going to be in moles calcium hydroxide. We want moles per liter, right? So now we're going to divide by how many liters of calcium hydroxide we have. Okay, that is our last step. So we'll divide by 0.005, just converting 5 mils to liters, dividing by 1,000. Okay, and then if you run this math through to 3 sig figs, you get 1.56 moles per liter calcium hydroxide. Okay, so that is the first piece. Second piece is how many equivalents of phosphoric acid are present? Well, phosphoric acid, it's going to ionize into 3 hydrogen ions and 1 phosphate, right? So this means 1 mole is equal to 3 equivalents, right? Well, you might have the mole number already from doing 0.4 times 0.013, but if we go 0.4 moles per liter times 0.013 liters, this is going to give us our number of moles, and then we know that 1 mole is 3 equivalents. Okay, so moles are done. This is going to leave us with equivalents. So 0.4 times 0.013 times 3, and we get 0.0156. You could put that in scientific notation as well if you like. Okay, but that is our number of equivalents of phosphoric acid. Okay, and then last part is normality, right? Normality, this is equivalents per liter. So we have 0.0156 equivalents divided by 0.013 liters of the phosphoric acid. So this means the normality of that phosphoric acid is 1.20. Okay.